Okay, hello everyone. Today our topic is about orbiting orbits. Okay, so let's move into the first part about orbiting bodies. Okay, so here you can find yours about light speed. As we all know that the light travels at a very fast speed in the universe, right? Or maybe you can say it's the most, or you can say the fastest seen in the universe. So for light, we can say the light speed equals to 3 times 10 8 meter per second. This is a constant value and doesn't change at every time and every substance, okay? It stays a constant value. So for light in the speed of light, we can say the speed formula we knew before that is equals to distance over time taken, right? And time taken, also we can written like put the here, time here, and just swap, sweep, and time, right? That is distance over speed, okay? So for some questions, it will ask you that, oh, maybe for here, it can find that the like satellites orbiting on its orbit, and you can using the speed to find the time taken. Okay. And also you can find some problems asking you that the light is traveling from this planet to another planet, and how much time taken or how much time delay for this. Okay. Always remember that time equals to distance over speed. So here you can give example right here. Like here, distance d equals to 5.8 times 10 9 meter, and speed here equals to the speed of light, and which means velocity equals 3 times 10 8 meter per second. Okay, so here we can use the formula that time taken equals to distance moving over time taken 5.8 times 10 9 over 3 times 10 8. Like here is meter per second. Okay, finally you can find the time taken here is 1.93 meter per second. Oh, sorry, maybe here is time taken in second, right? So here is time taken or time delay for here you have to traveling through the orbit. Okay. So to remember that in the universe and maybe in the solar system, most of the planets or more of the planets just traveling through the sun in an elliptical orbit. So maybe before we just considered it as like a circle, right? A very total circle. So for most of the time, elliptical has a property that there is a two center in elliptical. Because we can say that is focus of elliptical. So for the two focus, the sun is at one focus of the orbiting like orbit. So every planet just passes through like elliptical orbits. So we can say that there are two very special points. That is the closest point and the like the furthest point. Okay. So when moving to the closest point, you can find that, okay, so here maybe it's June or July in the Earth, okay. And when moving to the furthest point here, sometimes it's like December, like maybe like June, sorry, January or December, like these times, okay. So this is for the position and the time taken for this, okay. So every time you have to analyze the orbit, and here you can find there are different planets. Like Mercury orbital distance is like here, and you'll find the time taken is very short, 88 days, you know. And Venus is about 225 days, and Earth is about 365 days. Okay. So using this formula and using this data in the table, we can set that we can find Mercury is the closest planet to the Sun, right? So we can set if it's closer and the time taken will become smaller. Okay. So we can set closer planets. That means the time taken for rotation that is very small, right? And also we can set that the velocity is very big. So we can set that closer means the stronger or like a bigger velocity for the planets to motion. Okay, because this is for anything in the orbit. I guess it's not very difficult for you. Every time to remember that closer, which means bigger velocity. Okay, so here let's doing the exercise for this lesson. Okay, okay, trying to solve the problem, please. Okay, a little bit difficult. Okay, so I guess this problem is also a little bit difficult for you, right? So you want to calculate the distance traveled by the light in 1 year. Okay, so you can use in the formula like in 1 year, and the total time taken is like 365 days times 2.25 days times like 24 hours in a day and times 60 minutes in an hour and 60 seconds in a minute, right? This is total like seconds in 1 year, and you have to times the speed of the light. The speed of light is 3 times 10⁸ meter per second. Okay, and finally you can calculate the answer right here. Okay. So for this problem, always remember that distance formula, the motion formula, and the kinematics formula. Okay, it's very important. So today's lab is very short, and see you next time. Bye.